All right, gang, super cool video here. Seriously, if this doesn't grab you, then I don't know what to do for you. This is stuff that we're all going to encounter. Um, and again, I'm going to use TVM Sovereign. Uh, cool stuff. Um, so let's just get busy. Let's get into some things. Okay, so the Taggart family bought a house for 191,000. Decided to amortize. Amortize is just a fancy word for pay off. So they decided to pay off their loan by making equal monthly payments for 30 years. They negotiated an annual interest rate of 4.295. I say negotiated because I want it clear to you that you establish good credit. You can go in with some power and negotiate interest rates. So the first thing we would want to do is want to do our monthly payments. Guys, that's really simple. First thing we're doing, we're taking monthly payments over 30 years. So again, it's going to be 12 times 30, as we've talked about in the previous video. The interest rate that they've negotiated is 4.295. Okay. The present value of their home is 191,000. The payment, set it at 0. We'll come back and get that later. Future value, we want to pay off our loans. So that's going to be 0 and PYCY are 12 because we're making monthly payments. All right. So we can come back up to payment, hit our green key, hit our enter key, and we can see that our payment is going to be $944.64. Now, I'm going to show you how we work this with the formula. There's a formula that's really kind of complicated, so but we'll get into that too. But mostly, if we want a payment, we're going to calculate it with the TVM solver. Now, the next thing is how much interest will they pay over the life of the loan? Well, guys, that's really simple, right? It's a simple concept that we can always calculate the interest by taking how much we paid total, which is going to be $944.64 each month for 30 years, and subtract out the principal that we borrowed. So if we take the total amount we pay and subtract the principal, the amount that we borrowed, then that difference has to be the total interest. So guys, on a $191,000 home over 30 years, you're going to pay right at $150,000 interest. Seems hard to believe, right, that you would pay almost $150,000 interest. Your interest is almost the same as your principal. And usually a pretty good rule of thumb on a 30-year mortgage is your interest. Now this is a pretty good rate, 4.295. But it's not a bad way to get a pretty decent estimate. You know, if you're going to borrow buy a $200,000 home and you don't have your calculator with you, you can just about multiply that by 2 and say I'm going to pay $400,000 total. Divide that by 30 years times 12. Your payment's going to be somewhere around $1,100 a month. It's probably going to be a little bit of an overestimate. Your payment will probably be a little cheaper than that because interest rates are lower today. But that's a really good kind of a rule of thumb to get a pretty good indication of where your payments will be. But it's always best to check it out and get it down to the penny. All right, part C, what is their payoff after 1 year? Now, guys, the way this payoff works in your calculator, if you'll go back to apps and go to finance, and scroll down, you have something called a balance key. And if you hit your balance key, it'll copy and paste it back into your home screen. So you want to make sure it's on a line by itself. And this balance key works for the current information that you have in TVM Solver. So everything has to be entered, and the one you're trying to solve for, which in this case is our payment, has to have been solved for. So once you've got everything in TVM Solver the way that you want it, you can then go to your balance key and enter the period based on the PYCY setting. So what I mean by that is we want 1 year, so we have done everything in terms of months, so 1 year is 12 months. So the ending balance after 1 year would be $187,000, 805.32. So the calculator gives you a balance key. So after 1 year, your balance drops from $191,000 to $187,805.32. Now that helps us work the next problem, which says how much interest will they pay during the first year of the loan? Well, that goes back to a very simple principle of the total paid equals the principal plus the interest. Well, let's think about what the total that we've paid. The total that we paid here will be 944.64 times 12. Because over the first year, that's all we're looking at here. We're looking at the first year. We have paid 944.64 12 times. So 944.64 times 12, we paid the bank a total of $11,335.68. Now, the principal part. What did we do with the principal? Well, the principal took the loan of $191,000 and decreased it down to $187,805. So the principal part, we have taken the total amount. It has been reduced down to $187,805.32. So we have reduced the principal $3194.68. So the total amount that we pay has to be divided into two things: the interest plus the amount that has reduced the principal. And again, we started out at month 0, we owed $191,000. Our calculator tells us after 1 year we still owe $187,805. So the difference in those has to be the amount that we've reduced the principal. Well, the rest of this has to be the interest paid. And if my calculator is correct, our interest paid is $8,141. So of the $11,335.68 that we paid the first year, almost, 70% of it, 75% went to interest, and only about 40% or something, 35, something like that. We can figure it up. We can easily do that. We can take the 3194.68 and divide by the total amount that we paid. So 28% of the amount that we paid the first year went to reduce principal. So 72% of the amount we paid the first year went to the bank just as interest. Now, a little tougher problem is C. How much interest will they pay during the last year of the loan? So we got to get two things here. We got to get the balance starting the last year, and we got to get the balance at the end of the last year. Well, guys, we know that the balance at the end of the loan is 0. But what we got to do now is we got to come in, and I want to clear this out. We got to get the balance going into, let's see, what is that, 9? Okay, I have to remember that. We got to get the balance going into the last year. Well, we financed this for 30 years, so I need to know starting the 29th year for all those months what the balance is. Well, the balance is $11,076.35. Now again, very simple principle here. The amount that we paid total is going to go into two parts. How much it took to reduce the principal plus the interest. So first of all, let's figure out how much we paid total. Well, it's going to be the same thing before, right? Our payment is $944.64 times 12. So in the last year, we paid $11,335.68. We reduced our principal from $11,076.35 down to zero. So guys, kind of a duh factor. We reduced our principal down $11,076.35. Well, guys, the rest of that has to be interest. So if we take $11,335.68 and subtract from that of $11,076.35, we only pay $259.33 interest in the last year. That's all we paid. Huge difference, right? Huge difference in $81.41, the interest that we paid in the first year, versus $259.33 that we paid interest in the last year. The reason why? The power of compounding. The first year, some of that money reduced the principal, so starting the second year, we had less money on principal that the interest was calculated. The third year, we have less principal. The fourth year, we have less principal. The fifth year, we have less principal. Sixth year, and down to the 29th year, we have the lowest principal starting in a particular year. So that's why the interest is the smallest. Now, the next thing, how much interest would they save if they negotiated an annual interest rate of 4.1 instead? So instead of 4.295 that we started with way back up here, would it have mattered if we negotiated 4.1 instead? And I thought about this once. I used to play golf with a banker. He was a good friend of mine, and I was going to buy a house, and I remember the interest rate that he was going to give me didn't seem like it was much more. In fact, it seemed like it was very comparable. But sometimes very little interest rate over a loan can make a difference. Well, guys, we know that at the 4.295%, that our payment was $944.64. What we need to do now is we need to come in and calculate the payment as if it was 4.1%. Well, guys, with your calculator, that's something that's done very easily. At 4.1%, your payment would be $922.91. And my buddy said, well, come on, Doug, it's only $22 difference. All right. Well, at get this where you can see it. Okay, at 944.64, here's what's going to happen. 944.64 times 12 times 30. That's how much you're going to pay. And now let's subtract out, if we paid 922.91 times 12 times 30, you can see the difference is almost $8,000. And of course, my buddy's still telling me, man, you're my buddy. You're my buddy. Come on, come on. I need your business. And I'm like, well, if you need your business, then reduce it $7,822 over the life of the loan. If I'm a good enough friend to you to pay this extra, you should be a good enough friend to me to represent your company to get my business. All right, so I played hardcore with him. And finally, I remember saying, let's meet me in the middle someplace. Man, he didn't, so we didn't do business. But he's still a friend of mine, so that's cool. All right, G, how would the amount of interest they pay over the life of the loan change if they negotiated quarterly payments instead of monthly payments? Well, guys, anytime you pay less payments per year, you're going to pay more money. But let's figure out how much more we would have paid. So, again, with the calculator, it's simple stuff. We would have 4 payments per year times 30 instead of 12. So we do the quarterly. We're going back to this 4.295 thing. Our rate is, the value of the house is still starting at $191,000. But our PYCY both have to be changed to 4 because periods per year and compounds per year have to match up the number of payments that we make. So we go back up to payment, hit our green key, enter, we see that our payments would be $2,838.89. Now, guys, you can get, that's not right. You can get sloppy there. Just remember that you're making quarterly payments, not annual payments. So we would take 2838.89 times 4 per year times 30. So gang, you would have paid a total of $340,000 and 666.80. That's how much you would have paid total. Now we can subtract out what we would have paid the other way. Monthly payments times 30, and just by making quarterly payments, it's going to cost you about $600 more over the life of the loan. So not a tremendous amount over 30 years. But nevertheless, what I want you guys to know is the less payments you make per year, the more you're going to pay over the life of the loan. But sometimes it's not substantial, especially if you figure out that you're paying this over 30 years, so it's only about $20 a month that it actually costs you. All right, gang. Number 2. Let's change up the dynamics of the problem. So the Taggart family also would like to begin saving for retirement. They are considering 2 options. Option number 1, they make a lump sum investment of $100,000 compounded monthly at 3.95%. Annual interest rate for 25 years. The next one, they have a lump sum investment of $25,000, but they're going to add an additional $25,000 per month for 25 years. All right, so calculate the ending balance for each option. So, guys, this is, again, a difficult problem. If you use the formulas, but if you use your calculator, these turn out to be pretty simple, okay? So let's go into option number 1, again, TVM solver, and let's set up the dynamics of the problem. So the first thing we know is that we are compounding monthly. So we start out with 12 times the number of years, which is 25. Next thing we do is the interest rate, which we see is 3.95. Our present value is 100,000. We're not going to add anything to it. And our periods per year, monthly, so obviously this is 12. Come back up and get your future value, green enter. So you would end up with a whopping $268,000 16.48. So you'd end up with $268,016.48. Now the next option is different. The next option, we still add to it per month. So guys, we still got the 12 times 25. The annual interest rate is still 3.95. I don't know why I'm typing over it. But this time we have a lump sum of $25,000, and we want to add $250 per month. Since we're adding per month, we still have 12 down here, so we go get our future value, and we end up with $194,611.58. All right. Now, the total amount out of pocket. Which is going to be needed to calculate some stuff coming up. Well, here the only thing out of pocket was the original amount that we started out with at $100,000, right? But guys, the second option, the total amount, was the $25,000 that we spent up front, plus that the initial $250,000 per month for the next 25 years. So out of pocket, we also spent $100,000. And to be honest with you, that's the way I set it up. I wanted the out of pocket to be the same amount, but I wanted to create different ending balances to show you the power of compounding, actually. So how much interest is earned in each option? Well, if you got $100,000 total out of your pocket and you end up with this much, then the interest has to be the difference. And option 2, the same dynamic, guys. How much do you end up with? How much did you put it in your own pocket? So 94,611.58 is the amount that you earn interest in each option. Simple dynamic there, guys. Simple relationship. You can look at, again, how much money you contributed to the account, see what the account is worth. The difference in those two things has to be the interest. All right, so what happens? Why is this substantially more? I mean, it's almost double. It's $74,000 more money, option 1. Well, what happens with this option up here with the $100,000 being put in all at one time? That $100,000 sat there for the entire 25 years and worked for you. So day one, you had $100,000 drawing interest at 3.95. You didn't have that here. You had the $25,000 at day one, and then 1 month later, you added another $250 to it. So after the first month, you had $25,250 drawing interest. Up here, after the month 1, you had $100,000 plus the interest that it had drawn for the first month. Okay. Now compare the balances for each option at the end of 15 years. Well, we got to go in and set it up. So let's set up the first option first. So we've got 30, 395. We'll have 100,000 here. No extra money. Calculate the end, 268,000. Now we've got that in there, so we now can go look at our balance. So I'm going to hit second function quit to get out and go back to the blank home screen. I go to apps. I go to finance. I remember before that was at number 9. And I want the balance after 15 years, so I have to go the number of compounds times the number of years that I want the balance. So the initial investment, the investment of $100,000 is going to grow into 01 is option 1, it would have been 180,674.52 after the 15 years. Now, to get option 2, I have to go in and set the calculator up for that situation. Well, I still have 12 times 25. I still have the same interest rate because my present value starts out with less money, but I add a payment of $250 each month. So I've got to solve for this. I get the 194,611 like I did before. Now I can go second function entry to get that same thing because it's now being calculated on the new values I have in TVM solver. So I have 106,440.41. So I have about $74,000 more in the lump sum investment that was bigger than the smaller lump sum where I put $250 extra per month. You know what, guys? Honestly, in the real world, it's sometimes hard for people to come up with $100,000 where they could just invest it lump sum. In fact, it's sometimes hard to come up with $25,000. But we're going to look at problems throughout. You know, what if we start out with nothing and just invested $250 per month for maybe 10 years, and then the next 10 years we invested $500 a month, and then so what would we end up with? And it turns out those are very doable scenarios with the calculator. So again, we ended up option 2 about $74,000 less. All right, how much interest is earned in the last year for each option? Well, guys, we have to find the balance for each option. Okay? Now, guys, this is a little tougher. All right, so we'll walk through this one much slower. So option number 1, guys, you gotta get the calculator set up. Well, I'll tell you what, we've got this information in here right now for option number 2, don't we? So let's just go ahead and do the balance for 24 years. So the balance at the end of 24 years for option number 2 is $253,000. Well, that can't be true. What did I do there? Oh, shoot. Guys, I messed up. We're still months. Duh. All right. And we need 24 years there. Yeah, that was just silly. So that was just not good at all. All right, so 184,149.61. All right, now let's go back in, set up the first scenario. So same thing, 100,000. The point I'm trying to make here is you've got to have the information in that TVM solver exactly to go in and calculate balances. Okay, so I've got that. So second function quit, and I need the same thing, 12 times 24. So the bending balance there would be 257,652.91. Guys, these numbers should be really close too because we're using the same procedure. All right. Now let's think about what happened here. All right. In that last, I'm sorry, in option number one, what happened in option number one? In the 24th year, we began with $257,000, 652.91, and we ended with, as we saw back earlier, $268.16 and 48. So 257,652.91, and we ended with 268. So the difference, so 268,016.48 minus 257,652.91, we gained $10,363.57 the last year. Now, we didn't put any more of our own money in on that because that's the option where the $100,000 was put in initially and nothing else was added to it. So that's what we have for option number one. In the last year, again, this is what we're doing. How much interest is earned in the last year for each option? Now, for option number two, the 24th year balance at the end was $184,149.61. And the 25th year ended up, as we saw earlier, of $194,611.58. Now, if we subtract those two numbers, we get 10,461.97, right? But we got to remember, we put $250 of our own money in that account the last, no, 250 times 12, my bad. We put 250 times 12 in that last year of our own money, so that has to be subtracted out of the difference because we can't treat this entire 10,461 as interest because there was some money that was put in there. So if we subtract out 250 times 12, the interest in the last year was $7,461.97. And that would make sense because it would make no sense whatsoever for there to be more interest earned in the last year on the lesser amount than it would be earned on the bigger amount. So we knew there was we should have known there was a red flag with this number being bigger than that one because we're calculating the interest on less money. And the fact is we did consider, some people don't consider, that you've got to subtract out the principal to isolate the amount of difference that is in interest. All right, guys, this is what we're going to be spending our time doing a little bit of here lately. I'll tell you what you can go on and expect. You're going to have some tricky quizzes. I'll have some videos that'll be put up, and I'll give you some scenarios, and you'll send me the answers, and I'll have them that you'll have to send them to me within a reasonable number of days. So it's going to be important that you that you watch the videos within the week that they're posted. And then we'll do some more of this stuff, as with my guidance in videos. So I think that's all. I don't think I have anything else for us to do. So that's good. So guys, that's it. Take care.